Given f of x is equal to mx plus 1 whenever x less than or equals to pi by 2 and sin x plus n when x is greater than pi by 2 is continuous at x is equal to pi by 2. When the function is continuous at x is equal to pi by 2, so we can say the left hand limit extends to pi by 2 minus f of x is equal to the right hand limit extends to pi by 2 plus f of x and is equal to the functional value f of pi by 2. So here we can say the limit exists. So let us consider the left hand limit. Left hand limit for the function at x is equal to pi by 2. So we can write limit extends to pi by 2 minus f of x, which is equal to limit extends to pi by 2. Since it is pi by 2 minus, so below pi by 2 function should be considered, that is mx plus 1. So we can write here mx plus 1, which is equal to m times of pi by 2 plus 1. And now right hand limit. Let's consider right hand limit. Limit extends to pi by 2 plus f of x. When it is above pi by 2, we shall consider the function to be sin x plus n. So we can write limit extends to pi by 2 sin x plus n, which is equal to, on applying the limit, sin pi by 2 plus n. Sin pi by 2 value is 1 plus n. Since left limit, right limit both are equal, limit exists. So left hand limit is equal to right hand limit. Since the function is continuous, so we can use m times of pi by 2 plus 1 is equal to 1 plus n, or we can write n is equal to m times of pi by 2. So which is our option C. N is equal to m times pi by 2. Option C is the right answer. If f of x is equal to x minus 4 upon mod of x minus 4 plus a when x is less than 4, and when x is equal to 4 it is a plus b, and when x is greater than 4 it is x minus 4 upon mod of x minus 4 plus b, is continuous at x is equal to 4. Since this function is continuous, so we can say the left hand limit at x is equal to 4 is equal to the right hand limit at x is equal to 4, and which is equal to the functional value, that is f of 4. Let us consider the mod of x minus 4 at the point x is equal to 4. Mod of x minus 4 we can write x minus 4 when x is less than or greater than or equals to 4, and negative of x minus 4 when x is smaller than 4, as per the definition of mod x is equal to x when x is greater than or equals to 0, and negative x when x is less than 0. So consider the left hand limit now. Left hand limit extends to 4 minus f of x, which is equal to limit extends to 4. Since it is below 4, we need to consider the function x minus 4 divided by mod of x minus 4 plus a, which is equal to limit extends to 4. Since it is below 4, we have to consider negative of x minus 4 for mod of x minus 4. So we can write x minus 4 divided by negative of x minus 4 plus a, so which is equal to limit extends to 4. It's the negative 1 plus a. So it is an independent of x, so we can write a minus 1. And right hand limit extends to 4 plus f of x is equal to limit extends to 4. It's above 4 means we can consider the second x minus 4 by mod of x minus 4 plus b, which is equal to limit extends to 4. Since it is above 4, we need to consider x minus 4 for mod of x minus 4. So we can write x minus 4 upon x minus 4 plus b, which is equal to limit extends to 4, 1 plus b. Again here it is an independent of x, we can directly write 1 plus b. And functional value at x is equal to 4, it is given a plus b. Since we know that left hand limit, right hand limit and functional value, all the three are equal. So we can write here. So we can write left limit is a minus 1 is equal to a 1 plus b is equal to a plus b. So by equity comparing, so we can write, so comparing a minus 1 is equal to, or a plus b is equal to a minus 1. So we'll get b is equal to negative 1, and comparing a plus b is equal to 1 plus b, these both. So we'll get b is a is equal to 1. We'll get a is equal to 1. So b is equal to negative 1 and a is equal to 1 when the given function is continuous at x is equal to 4. So which is our option? A1 b negative 1 is option B. Let's see assertion and reasoning type question. The modulus function f of x is equal to mod x is differentiable for all x belongs to R is our assertion. And the reason the function f of x is said to be differentiable if it is differentiable at every point on its domain. So considering the assertion, the modulus function f of x is equal to mod x. So this is y is equal to mod x, and we know that the modulus function will have the sharp edge at the point at x is equal to 0. So where we can see that infinite tangents can be drawn at the point x is equal to 0, and hence differentiability is not defined. So we can say that mod x is, means y is equal to mod x or f of x is equal to mod x is not differentiable even though the function is continuous, but this function is not differentiable at x is equal to 0 since it has a corner point. At x is equal to 0, so infinite tangents can be drawn. And coming to the reason, and we know that a function f of x is said to be differentiable if it is differentiable at every point on its domain. Yes, according to the definition of differentiability, at every point on its domain, the function must be differentiable. Then only we can say the function is differentiable. So reason is true and assertion is false. So we can go with an option D. If y is equal to root of sin x plus y, then dy by dx is equal to. So it's given y is equal to square root of sin x plus y. Let's do squaring on both sides. So we get y square is equal to sin x plus y. Now let's differentiate with respect to x. So we get differentiation of y square is 2 into y. Since we are doing differentiation with respect to x, so as per the chain rule we must write dy by dx is equal to, so differentiation of sin x is cos x plus y differentiation is dy by dx. So we can write now 2y dy by dx minus dy by dx is equal to cos x. So taking dy by dx common, so we can write 2y minus 1 of dy by dx is equal to cos x, or we can write dy by dx is equal to cos x upon 2y minus 1. So dy by dx is cos x upon 2y minus 1, which is our option A. So option A is the answer. If x is equal to t square and y is equal to t cube, then d square y by dx square. Given x is equal to t square and y is equal to t cube. Differentiating with respect to the variable t, so we can get dx by dt is equal to differentiation of t square is 2t, and here dy by dt is equal to t power 3 differentiation is 3 into t to the power 2, and now dy by dx is equal to, in parametric form, dy by dt upon dx by dt, which is equal to 3t square upon 2t, that is 3 by 2 times of t. And now, since we required d square y by dx square, which is d by dx of dy by dx, you can write d by dx of dy by dx is 3 by 2 times of t, that is 3 by 2 times differentiation of t with respect to x is dt by dx, and we know that dx by dt is equal to 2t, so we can write dt by dx is equal to 1 upon 2t, so which is equal to, here 3 by 2 into dt by dx is 1 upon 2t, so which is 3 by 4t. So we can write d square y by dx square is equal to 3 upon 4t, which is our option D. If y is equal to cos inverse x, then d square y by dx square is equal to, since y is equal to cos inverse x, so we can write cos y is equal to x. Now differentiating with respect to x, so we get differentiation of cos y is negative sin y into dy by dx, since the differentiation is with respect to x, and is equal to differentiation of x is 1, that is dx by dx is 1. We can also write here dy by dx is equal to minus 1 by sin y, that is dy by dx is equal to minus cosecant y. And again now differentiating with respect to x, we get dy by dx of dy by dx is equal to d by dx of minus cosecant y, so that is d square y by dx square is equal to differentiation of cosecant is minus cosecant into cot, so we can write minus of minus cosecant y into cot y, and since the differentiation is with respect to x, so we can write into dy by dx, so which is equal to, it's a cosecant y into cot y into, again dy by dx is minus cosecant y, so we can write into minus cosecant y, or we can also write negative cosecant square y into cot y, so which is our option C. So we can go with an option C. If y is equal to sine of log x, then prove that x square y2 plus xy1 plus y is equal to, and similar question, the same exactly, y is equal to sine of log x, x square d square y by dx square plus x dy by dx is equal to, since we know that y1, which means to say dy by dx, and y2 is d square y by dx square. So the given function y is equal to sine of log x, the differentiating with respect to x. So we get dy by dx is equal to differentiation of sine is cos of log x into again differentiation of log x is 1 upon x, applying the chain rule, or we can write x into dy by dx is equal to cos of log x by doing cross multiplication. So this can also be written xy1 is equal to cos of log x. Now again differentiating with respect to x. So applying the UV rule here, x into dy dx of differentiation of y1 means differentiation of y1 will be y2 plus y1 into differentiation of x is 1 is equal to differentiation of cos is negative sine of log x into again log x differentiation is 1 upon x. So we can write cross multiplication x square y2 plus x into y1 is equal to negative sine of log x, and this negative sine of log x is minus y, that is x square y2 plus xy1 is equal to minus y, or we can write x square y2 plus xy1 plus y is equal to 0. So x square y2 plus xy1 plus y is equal to 0. So which is our option D here. And in this case we can say x square y2 is nothing but d square y by dx square plus x into y1 is dy by dx is equal to negative y. So in this later case we can say the option is B, minus y. Okay. The volume of the cube is increasing at the rate of 8 centimeter cube per second. How fast is the surface area increasing when the length of an edge is 12 centimeter? So let us recall the cube. If the length of the cube is x, then its surface area is 6 times x square and its volume is x power 3. Let us consider here, let x be the length of an edge of given cube. So the volume will be, say volume V is equal to x power 3 and surface area let us consider capital S is equal to 6x square. Now differentiating with respect to t, so we'll get dv by dt is equal to 3x square. Since we are differentiating with respect to t, so you must write dx by dt, and which is given the volume of cube is increasing means positive at the rate of 8 centimeter cube. So we can write which is equal to 8 centimeter cube per second, that is 3x square dx by dt is equal to 8. So which implies dx by dt is equal to 8 by 3x square. Let us keep it as aside 1. And now here surface area 6 times x square. Now again differentiating with respect to t. So we will be getting ds by dt is equal to dx by dt is equal to 6x square differentiation is 6 2s are 12x into again dx by dt since we are differentiating with respect to t, which is equal to 12x into, since from 1 we can write 8 upon 3x square. So we can write this is from 1. So ds by dt is equal to, so 3 4 times 4 8s are 32 times x and x square 1 get cancelled, so 32 upon x. And now surface area we need to find whether it's increasing at the length of an edge 12 centimeters. So we need to find ds by dt at x is equal to 12, which is equal to 32 upon 12. So 4 8 times and 4 3 times. So we can say 8 upon 3 since it is a surface area. So we can add centimeter square and times second, centimeter square per second. So 8 by 3 centimeter square per second is the answer, which is our option D. Surface area of a cube is increases at the rate of 360 centimeters square per second. How fast is the volume of the cube increasing when the edge is 10 centimeter long? Let's recall the formula for cube. When the length of a side is given x, then its surface area is equal to 6 times x square and its volume is equal to x power 3 cubic units. And here given surface area is increases at the rate, let x be the length of an edge of cube given cube, so that surface area is equal to, let us take capital S is equal to 6 times of x square and volume V is equal to x power 3 cubic units. So differentiating with respect to S, sorry, T. So we have ds by dt is equal to, so d by dt of 6x square, and since it is given ds by dt rate of change of surface area is given 360, so we can write here 360 is equal to differentiation of 6x square is 12x into dx by dt, or we can write dx by dt is equal to 360 divided by 12x. So 12 how many times? 30 times. So we can write 30 upon x. So you can make a note, dx by dt is equal to 30 upon x. Keep it separately. And now volume, since volume is equal to x power 3, so differentiating with respect to t, so we get dv by dt is equal to d by dt of x power 3, which is equal to 3x square into dx by dt. And now let us substitute dx by dt, say 1. So dv by dt is equal to 3x square into 30 upon x, which is equal to 90x. And since we want volume of cube increasing when the edge is 10 centimeters, so let us consider dv by dt when x is equal to 10, which is equal to 90 into 10, that is 900. Since it is a volume, so we can use cubic centimeter, and with respect to times, so second, so centimeter cube per second. So 900 centimeter cube per second is the answer, which is our option D. The area of an equilateral triangle increases at the rate of 10 root 3 centimeter square per second. Then find the rate at which its perimeter increases when its side is 10 centimeter. So let the length of each side of an equilateral triangle each side of an equilateral triangle be x centimeter. Then we have area of an equilateral triangle, or its area A is equal to root 3 by 4 into x square, and perimeter, say P is equal to 3 times the length of the side, that is 3x. We can say this is centimeter and this is centimeter square. And since it is given dA by dt is equal to 10 root 3 centimeter square per second, and we have A is equal to root 3 by 4 x square. So differentiating with respect to t, so dA by dt is equal to root 3 by 4 into differentiation of x square is 2x into dx by dt. So from here dA by dt is 10 root 3, so we can substitute 10 root 3 is equal to root 3 by 4 into 2x into dx by dt, or we can write dx by dt is equal to 10 root 3 into 4 divided by root 3 into 2x. On simplifying, so we can say it is 20 upon x. So let us keep it aside. Dx by dt is equal to 20 upon x. Say this is 1. And now the perimeter is given. Since the perimeter is 3 times x, differentiating with respect to t, so we will get dp by dt is equal to 3 into dx by dt. And from 1 dx by dt is 20 upon x, so we can add 3 into 20 upon x, that is 60 upon x, which is dp by dt. And we need to find the rate of perimeter at the side of length is 10 centimeters, so we can write dp by dt at x is equal to 10, which is equal to 60 upon 10, which is equal to 6. Since the perimeter, so we can use a centimeter and time is second, centimeter per second. So 6 centimeter per second, which is our option D.